splitting instructions. Basically they'll just say, yeah, move some register to another register, add something to that register, subtract it, things like that. And I tell it to run, and yeah, it doesn't like you telling it to run data, so it gives you a warning. But and then it's running, and I have to change to IE, and it pops calculator. So yeah, sometimes you need to tell it to activate the component. I think it was in the wait for multiple objects or something. So what you just saw was just provide exploit, a proof of concept. Yeah, I simulated the actual exploit itself using Ollie, and also so you could have a look and see a little bit about what the shellcode looked like. And some of it requires some extra tools. So these notes here, if you decide to download it, it was developed using Cygwin and in the Windows environment, and they managed to break X, or break ImageMagick at some point. But there's a workaround for that, which was posted somewhere. And the output's only for 24-bit displays on Windows, because that's the most common target, really. And other platforms and bit depth, yeah, exercise for the reader.
So I tackled PNG.
So how do you detect these type of things? And how do you stop people detecting these type of things? And how do you stop people stopping detection? Basically, you can look for big files. But compression is really good on these files. I made a 8K by 8K light gray image with shellcode. So it was 192 meg uncompressed. The PNG format of that was 83K. And then when it was transferred using mod gzip, it was just over 1K. So it's not going to be a large file. However, you're going to have it quite a bit larger with an actual image stored into it. That was probably the most redundant case you could have, so it compressed the best. The images tend to be larger than a normal file, but not hugely so. They're scaled up images, which just means they have a lot of redundancy added, and that's what compression gets rid of, just the redundancy. So you're repeating the same stuff over and over again, and it just compresses it pretty well. The filtering also reduces the total information which is stored in the information. The filtering to make it so you only have valid no-op bytes. So rather than have the full range of 256 values each pixel can have, you have quite a bit smaller than that. There tends to be more bits overall in an image than the same image which has been scaled up. But so overall, they're slightly larger. You could look for images with large dimensions. But assuming you can read through the mod gzip, then yeah, that would work against the method we've described. But if you make the image half the size in each dimension, you can just use 4 images. Or if you make it a third, you use 9. Or use 4, well, it's not quite that simple. There are some other tricks you need to use, like using quite a few more images, just because of the way memory allocation works. You could look at, basically, we remember the byte frequency graphs from before with the spikes and that unknown hacker. The histograms, they were for normal images and the no-op sleds, and when you looked at those, they looked totally different. But if you knew where you're going to land in the image, you can only modify the parts which are before that to be it, and you can have the other parts cancel out any problems in it. You can tell roughly where you're going to land in an image also using page alignment tricks. Basically, you only have to know the last 3 bytes of where you're going to land. And if you repeat only the modifications over the parts after where you're going to land, and you repeat that every page size, you can just keep the rest of the page the same and just modify everything to cancel out the analysis they could do. However, you might be able to then slice up the image and analyze each slice independently, look for variations in the variations on there, but then you're just starting to get to a lot of work, which isn't going to help much. Your IDS would have to be very smart and very smart, because you need to know what the targeted program is and how the targeted program is going to handle that particular image format. I mentioned very briefly earlier the gamma chunks, which and the color correction stuff. These control how things brighten as the value increases. Right, so it changes basically the rate at which the brightness grows. What's the default gamma for the target application if you haven't got one in there? Does it actually read it from the file if you specify one? What if the file is slightly malformed, like you've got 2 gamma tags, or you put the gamma tag after the image data? And does it handle it correctly, or does it do something weird? And what about alpha, which is the transparency? Adding stuff like that to it, where does the compositing happen? Where does it mix it with the color underneath? And what is the color underneath? And how many files which expand to over 100 megabyte, all of which could have shellcode in them, can your IDS system analyze per second, compared to how many, If your IDS can emulate the browser, can you own the IDS at the same time? You also might be able to use some techniques which were mentioned in the paper on which is called language trees and zipping. It was basically, the idea was they used gzip on a bunch of texts from different authors, and were able to identify the authors just by the compression ratios. They got a 93% success rate, and I think 93% for an IDS is probably a bit low. But it should be really easy to do. A 15-year-old won a science fair using this technique. He basically demonstrated that William Shakespeare could have been Christopher Marlowe by using this technique, and if you don't know who either of those people are, you should Google. It's good to get culture. Each of these interesting file types is already compressed. which it may save some effort, both for you and for the IDS, if it works. PNG uses zlib, which is the same type that they use with the gzip compression. GIF uses LZW, and JPEG uses the Huffman encoding on the coefficients. So you've already got the compression happening for you, so that may help. What else can you use a big file for? You can create arbitrary structures with pointers in them, which point to valid locations. I said before, I was talking about the changing the last three numbers of an address. I don't think anyone knew what I was talking about. Okay, in any address which ends in XYZ, every time you repeat it over 4K, the XYZ is going to be, you can make that reference the same structures. So then you can create just about any structure, and even those which need valid pointers to other structures, using the same idea as where you land your shellcode. You can predict the memory range which is going to be available. You can't make this necessarily blend into the image with just any old structure, so you could use other tricks. Like one thing that works, which is kind of cheating to call it pun code, is to put in a background image